Hi, good morning, class, or good afternoon. Is this Mr. G, Mr. Garcia? We went ahead and did 1.5 yesterday, the beginning, example one. So let's go ahead and recall the essential question. So the essential question was, how do you simplify expressions involving a negative exponent? We went ahead and filled this out. Now you did two things. One of two things. Okay, you either filled this out on paper. So you have this paper right here. You filled it out here, okay, on this paper like this, because you have it still, or you did it virtually. You actually typed it in there. Okay, so let's see how this looks when it's typed in there. Okay, let me show you. Let me go ahead and show you guys. All right, so when you go ahead and type it in virtually, it should look something like this. Okay, when you're typing it in, you're going 2 times 2 times 2 times 2, and then this is 16. You keep going like that, and then you should be noticing that these are going by half, right? Half going down, right? And then that I explained that in the video already. And then it goes half, 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 half. It keeps going down. Okay. Now, one thing that you want to notice, once it gets to 2 to the 0, 2 to the 0 is 1. Okay. What I want you to notice is that anything, once the exponents go below 0, like -1, -2, -2, because these are getting smaller, yes, the exponents, the exponents are getting smaller, but also the numbers are getting smaller. Do you see that? 1/2, 1/4, 1/8, 1/16. It's actually getting very, very close to 0. If you keep going, it's going to keep getting very, very close to 0. I want you to see that. I want you to understand that. So regardless of what this number is, what the base is, the base could be 3 to the 4th, 3 to the 3rd. It could be that. It could be 5 to the 4th, 5 to the 3rd. Whatever this number is going to go down once you keep decreasing the integers. Okay, once you keep decreasing the exponents. Okay, so this is just an explanation of how we get from here to here, from here to here. Okay, this is an explanation of it. All right, that's what this means. Now, at the end of the day, you're not always going to do this. You're going to see today in example number 2 that we're not going to always be doing this. But we need to understand that 2 to the 0 is always 1. And 2 to the -1 is always 1 over 2 to the first. Okay. And then 2 to the -2 is always 1 over 2 squared. Okay. That's what that means right here. 1 over 2 squared, 1 over 2 to the third, 1 over 2 to the fourth. And we're going to go ahead and actually summarize this here. We're going to go ahead and I'm going to go ahead and give you kind of like the shortcut. Okay. This is the long way of doing it, but I'm going to give you the shortcut explanation today. All right, guys. All right, so on this one, if you're doing it virtually, okay, if you're typing it in there, you're going to type this in there. So it's 1 over, and then it's going to be a base, and then this is a positive plus exponent. So you're always going to have, anytime you always have a negative exponent like this, you're always going to put a 1 in the numerator, the division sign, and then on the bottom is going to be whatever the base is. In this case, the base is 2. And then you're going to put the exponent is going to be a positive one. Okay, another way to rewrite this is 1 over base x, and then this is a positive a. A means it's a positive exponent. Okay, that's how you rewrite negative exponents. Okay, and then on this one, how do you simplify powers that contain a 0 exponent? Any exponent to the 0 is always 1. Any exponent to the 0 is always 1 because of this. Okay, and then you'll probably see another video on this too. Any exponent, any power to the 0 is always 1. So x to the 0 is always 1. X could be 2, 3, negative. Anything to the power of 0 is always 1. Okay? Now, one last thing for those of you that are doing it virtually on here, the way you do 2 to the first like this, you have to make sure you press Control on your keyboard, Control period. Control period, then it'll move up like that. Then to get it back down, press Control period again. Okay? If those of you that are doing it in the slides. If you're still writing it on here, then you're okay. But you got to get used to doing the slides because next week we're only going to be using slides, not the paper, because you notice this is our last paper. Okay? All right, so we are going to go ahead and move on to example number 2. Okay, so we're going to actually solve these problems here. We're going to have, it's asking, what is an equivalent expression to the following? So these negative exponents right here, we're going to turn them into positive exponents. It's going to be an equivalent. Okay, it's what we did up here, how we converted these. Okay, if you haven't seen how we did these, then go ahead and look at the earlier video or the earlier lesson. Okay. All right, so let's go ahead and do example number 2. All right, so how do we what is an equivalent expression to the following? So 7 to the negative 2. Number 1, 7 to the negative 2. So if we remember from earlier, okay, so the way they changed this one is you put a 1 on the numerator, you put a fraction bar, and then you put whatever the base is, whatever the exponent is, you put it as a positive. So here we go. So let's go ahead and do the letter A. So letter A is going to go like this. Okay. I'll go ahead and write it over here, this one. 1 over x to the positive A. That way I don't have to keep going up there. All right. So right here. So equals. So we're going to have 1 over, and then the base is 7. And the exponent is negative 2. So now it's positive 2. And then this becomes 1 over 7 times 7, which equals 1 over 49. Okay? Got that? All right. So whatever it is, whatever the base is, you put it on the bottom, and then the exponent is negative 2, so you turn it into a positive. Now, if you were to put this into a calculator, guys, this would show up as this, and then it would turn it into a decimal. It's the same thing. Okay, now let's go ahead and do B. So again, so the base is, so it's 1 over, and then the base is x, and then the exponent is negative 4, so it's going to be a positive. And we'll go ahead and expand it. X, 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 x. There it is. We're done with that one. So what I want you to do now is I want you to go ahead and do G and H. You do G and H. Okay? Get it to this point right here. If you don't know what it is in actual this, then you can leave it blank. You can leave that part out. But I want you guys to go ahead and do G and H. Go ahead. All right, now for letter C, here's letter C. If we remember for letter C, anything to the power of 0 is 1. So your answer here is easy. It's 1. And why is it 1? 5 to the first over 5 to the first. Isn't that 1? Anything divided by itself is 1, yes? So when you do that, your answer is 1. That's the explanation of why this is 1. Okay, so now you guys go ahead and do I. Go ahead and do I. All right, for D, E, J, and K, now you notice they're already in fraction form, right? They are already like that. 1 to the 8th to the 1 over 8 to the 3rd power, right? They're already like that. So you're actually going to turn these into a negative exponent. That's what you're going to do. And you guessed it. You just go backwards. So on this one, it was 1 over 7 squared. Okay, we made this positive. This one's going to be backwards. So this one, your answer is going to be 8 to the negative 3. So this and this are the same thing. This and this are the same thing. Now look at E. So E, it's x, and then the 4, now it becomes a negative 4. Whoa. Easy, right? So letter J is like D. Let's go ahead and do J. Okay, and then go ahead and do K. All right, you're going to convert them into something that looks like this. Okay, you're not going to get an actual number today. That's fine. On these, I just want you to understand that from here you get this, from here you get this. Okay, you actually go from turning it into a positive exponent to a negative exponent. Before, we were trying to get it into a positive like this. See that? And now we're going backwards. Okay? All right, guys. So remember, you're going to do these. These are either typed in or you're actually doing the paper, okay? And then you're submitting it. You're taking a picture of it, okay? Hopefully, a lot of you guys are doing it like this. You're typing it in, okay? I know it might be a little bit more work, but that's the way we're going to go digital. All right, so let's go ahead and summarize what we did today. So your essential question is, how do you simplify expressions involving a negative exponent? So when it's a negative exponent, like this, we go ahead and put a 1 on top on the numerator, our fraction bar, and on the denominator, we're going to put the base of whatever it is, and then it's going to be a positive exponent. Okay? That's why for this one, it was 1 over 2 to the 4th. And then we expanded it. Okay? And then, how do you simplify powers that contain a 0 exponent? Anything to the power of 0 is 1, always. Okay? Doesn't matter what the base is. There is an exception, but we won't go over that right now. Okay? And then we went ahead and solved A, B, and G, and H. We went ahead and wrote an equivalent expression. So it was a negative exponent, now we turned it into a positive, and then we expanded it. Okay? For C and I, we had 5 to the power of 0, and we had 2.1 to the power of 0. Anything to the power of 0 is 1. And then on D, E, J, and K, we went ahead and actually turned these into negative exponents. So we went from this to a negative exponent. All right? Now, there's 2 more problems on the back, so let's go ahead and tackle those. So we had F and L. So what we're going to do for these is we're actually going to write them like this too. We're going to write them as a negative exponent, an equivalent expression. In order to do that first, we have to turn this into an exponent, a power. So what numbers multiply to get 27? So 1 times 1, no. 2 times 2, no. 3 times 3 is 9. But 1 more 3 would make it 27. So this would be 3 times 3 times 3. And this is 1 over 3 to the 3rd, which equals 3 to the negative 3. We're done with that one. This one, we're going to do the same thing. Let's see if you can figure this one out. Go ahead. So here's your answer for L. It's 1 over 10 times 10 times 10. And then 10 times 10 times 10 is 10 to the 3rd. When you change it back to a negative exponent, it's 10 to the negative 3. Okay? All right? So here's your answers for, if you got all the way to the end of this video, here's the answers for G, H, I, J, and K. Make sure you double check them with what you have. Okay? All right, guys. So brief summary. Anytime you have a negative exponent like this, 2 to the negative, 2 to the negative, 2 to the negative, 2 to the negative, 7 to the negative, all you got to do is put a 1 on the numerator, your fraction bar, and on the denominator, it's going to have the base and then the positive exponent. Okay? It's easy. And anytime you have to the power of 0, your answer is 1. And then when they give it to you like this, or it's already as a fraction, okay, and you have a positive exponent on the bottom, you just go ahead and convert it back. It's easy. Okay? You'll get 4 more problems at the end of the slide so that you can practice more of these. Okay? All right, guys.